If title bracket 5 keeps backfiring, you need BM25F field length normalization. We'll implement BM25F and map it cleanly to Elasticsearch, so weights stop being guesswork. By the end, you will understand why simple field boosts fail and how BM25F balances field length and importance, so search results actually match intent. I'm Professor Pi, teaching search and IR with simple Python. Search engineers often reach for headline boosts when title matters. They raise a field weight and expect magic. The result is often noisy rankings. Short titles get punished, or long bodies drown out precise signals. BM25F is a practical fix. It treats each field as its own partial document, normalizes for length, and combines those signals into a single score that respects both rarity and verbosity. Think of it like cooking. Title is concentrated spice. Body is a stew. Tags are garnish. You want a recipe that blends them, not a single spoonful of spice. BM25F gives you that blending rule. It adds IDF to reward rare terms, and a saturation curve so extra repeats stop adding value. We will build a tiny example with title, body, and tags. We will measure title lengths, then try a naive field-weighted term frequency approach. Upgrade that to BM25F. Evaluate with NDCG, and finally show how to mirror the same logic in Elasticsearch. That will make it easy to move from toy code to production. Now, we prepare the toy corpus and inspect field lengths. This snippet builds toy title body tags docs and computes average title length. It constructs a small in-memory corpus where each document has a title, body, and tags field. The code collects titles and measures their token lengths to compute a mean length for the title field. The top part creates the documents and normalizes whitespace. The middle extracts the title tokens with a simple split and records counts. The final step computes the average title length and prints or returns it, so we can compare to body lengths later. This gives a baseline for field length normalization. Next, we try a simple field-weighted frequency ranker. This snippet ranks docs using field-weighted TF across title, body, and tags. It counts term occurrences inside each field independently, multiplies those counts by a per-field weight, and sums them to produce a raw score per document. The snippet first tokenizes query and documents, then loops fields in order title, body, tags, applying the configured boosts. It shows how changing a field weight raises or lowers the influence of that field across all queries. The code uses plain term counts, so you can see where simple boosting fails. Long fields can still dominate unless you adjust for their lengths. Now we add IDF and a saturation rule to avoid linear term gain. This snippet upgrades to BM25F with IDF and saturation for multi-field scoring. It computes inverse document frequency to reward rare terms and replaces raw counts with a saturated function, so additional repeats give diminishing returns. For each field, the snippet applies a field-specific length factor to normalize counts before applying the saturation curve controlled by a single aggressiveness parameter. The code multiplies each field score by its weight and sums to a final BM25F score per document. It also shows how raising the saturation parameter makes term frequency matter more, while lowering it flattens the effect. Next, we measure how well the ranking matches graded relevance. This snippet evaluates the BM25F ranking quality using NDCG over graded labels. It maps each query to graded relevance judgments for the documents and computes discounted cumulative gain to capture utility at different positions. The snippet sorts documents by BM25F score for each query. computes DCG using the graded labels, and then normalizes by ideal DCG to get NDCG. By reporting a single NDCG number per query, you can see whether your parameter choices help ordering relevant items first. The code highlights how field weights and the saturation setting affect the NDCG trend. Finally, we mirror the same field-aware scoring in an index. This snippet uses Elasticsearch multi-match to mirror BM25F style field boosts. It shows how to translate field weights into the search engine by boosting fields in a multi-match query and by tuning index-level BM25 parameters where available. The snippet explains mapping choices that approximate BM25F, applying per-field boosts, enabling norms or disabling them for long fields, and keeping document structures so the engine computes length normalization. It also notes how production settings let you tune BM25, K1, and B centrally, while keeping per-field boosts for practical control. To bridge to real work, imagine replacing the toy corpus with your article index. Index the same fields. Expose the BM25F-like combination in a scoring script or tune your engine parameters, and measure NDCG on held-out queries before rollout. That path moves the idea from prototype to measurable deployment without guessing. Recap: BM25F combines per-field contributions with IDF and length normalization. Use it when fields differ in verbosity or importance, like title, body, and tags. One caveat: it introduces a few tunable parameters that interact, so blind boosting can hide issues. Next step: tune the BM25 K1 and B parameters while tracking NDCG, and adjust per-field boosts based on validation queries. If short, practical IR helps, subscribe and watch the IR videos.